You know when you watch a football game, right?
Right.
And every single play is reviewed and audited. The referee spots the ball, and the game's state changes definitively.
Yeah, there's no probability involved in where that ball goes. It's just
Right,
exactly that.
So what if the entire universe operated exactly the same way? Today we're doing a deep dive into this wild manuscript by Timothy J. Dillon that argues just that. Our mission is to uncover how this framework attempts to completely replace random probability with an absolute deterministic structure.
And it's a huge claim. I mean, he applies this to everything, like math, physics, finance, and even theology.
Okay, so let's unpack this. Dillon actually comes from the world of latency-sensitive sports betting, right?
Right. Building systems that track micro events in real time.
Exactly. And he took that strict requirement for exact, provable state changes and basically mapped it onto reality itself.
Well, what's fascinating here is the core premise. He says complex systems aren't random at all. They're driven by this constant tension between two forces.
Okay, what forces?
First, you have what he calls syntropy. Think of syntropy as the universe's mathematical blueprint for order and healing. And on the other side is dispersion.
Which is the chaos side.
Right, it's chaos or decay, like if you picture the shattering of a glass.
Okay, here's where it gets really interesting. Because to prove this underlying order, Dillon tackles one of the most famous, supposedly chaotic math puzzles out there.
The Collatz conjecture.
Yeah, the 3n+1 loop.
Right, so for those who don't know, the puzzle goes like this. You pick any positive number. If it's even, you cut it in half. If it's odd, you multiply by 3 and add 1.
And if you keep doing this, every single number eventually loops back down to the number 1. But no one has actually been able to prove why it always returns to 1.
Until this manuscript, Dillon introduces this thing called the Omega calculus to solve it.
But what is he actually doing differently with this Omega calculus?
Well, he proves that the loop is actually a forced structural descent. He maps out the math and basically eliminates 4 specific types of chaotic numbers.
The residual families, right? Families S, R, H, and C.
Exactly. By proving mathematically that these pockets of infinite chaos cannot exist, the numbers are essentially forced to return to order.
Okay, so he proves a math puzzle loops back to 1. I really have to push back here, though. How does solving an abstract whiteboard problem actually impact everyday reality, like your wallet or your smartphone?
Well, because the math governing that forced descent maps directly onto real-world chaos. Dillon's framework uses an engine to look at financial markets, for example.
Like the Omega Genesis structural risk engine.
Yeah. Instead of guessing where a stock goes based on past averages, it maps real-time micro-movements to those exact same 4 Collatz families.
Wait, really? So if family S is just a math concept on paper, what does that actually look like on a chaotic trading floor?
It looks like what traders call the slow bleed.
Oh, wow.
Yeah, the engine spots the mathematical signature of hidden algorithmic liquidations by institutional sellers long before the crash is obvious to the public.
That is wild. It basically finds the math hiding inside the crash. And the manuscript claims this predicts physical space too, specifically with telecommunications.
Yes, through curvature variable physics. I mean, think about a 6G signal hitting human tissue. Traditionally, we view that as just a random scattering event.
Right, the signal hits an obstacle and bounces unpredictably, which causes dropped calls or dead zones for your phone.
Exactly. But Dillon's model treats that biological tissue not as a random obstacle, but as a predictable mathematical roadblock.
So it routes around it.
Yeah, the network algorithms actively bend the signal around the tissue before the scatter even happens. It turns an erratic bounce into a perfectly stable connection.
Okay, so physical reality and financial markets both crave this deterministic order, but Dillon actually takes this a massive step further. He argues human morality is bounded by the exact same math. I mean, wait, how do we logically jump from 6G network algorithms straight to the Vatican?
I know, it is a massive conceptual leap, but it stays structurally consistent. He details these Omega Point Theorems, which were actually submitted to Pope Leo XIV.
Which is just crazy to think about.
Right. And the idea is, if the universe is fully deterministic, then moral actions are measurable forces. Syntropy is defined mathematically as the law of love.
Like a literal gravitational force pulling things together and lowering fragmentation.
Exactly. Which makes dispersion the mathematical proxy for sin. Structural evil is just maximum fragmentation.
So how does something incredibly human, like forgiving someone, work as a geometry equation?
Well, forgiveness becomes a state change where present syntropy has to definitively outweigh past dispersion.
Oh, I see.
It models compassion as a geometry that actively reduces the physical and emotional distance between people. A local act of kindness creates a measurable, cascading momentum of order.
So what does this all mean for you listening? We are talking about a radical shift from viewing the world as a series of random, unpredictable events to seeing absolutely everything as a predictable geometry.
Right, from a sudden stock market crash to the act of forgiving a friend.
Exactly. It's all interconnected.
Yeah, and if we connect this to the bigger picture, consider the implications. Every single action is recorded as a deterministic state change.
Just like that auditable football play we started with.
Yeah, exactly. And if syntropy really is the mathematical force of love, well, what does the measurable moral curvature of your own daily decisions look like?